Hello all. Today let us see about your signal flow graphs in control systems. I'm Hemlata from the Department of EEE in the College of Technology. And first one, that is signal flow graph, which is covered by your machine's gain formula. Here, see about the block diagram graph, that is block diagram to signal flow graph conversion. And first one, identify the label all signals on the block diagram. That is, what are the elements are present your block diagrams, and place a note for each signal. That is, in block diagrams, some of the gains are present. That is G1, G2, G3, same at all. That we have to draw the notes. That is which points. That is arrow marks points. We have to represent as nodes and connect the nodes with some of the branches and maintain the some correct directions and label the branches with corresponding transfer functions. And we have to convert. That is, we have to identify your positive feedback or negative feedback, and this is your directly have to go for the example, that is your block diagram is converted into your signal flow graph. That is, you are convert to signal flow graph. This is your block diagram. That is R of S, H2 of S, D of S, G of S, and H2 of S. Here label your signals. That is, this is your R of S value. This is your H2 of S value, and E of S error signal, and U of S, H2 of S. Your output is Y of S. This is your each signal nodes. And next one is a your block diagram. This is your example block diagram. We have to find the values. This is R of S to your H of S. In between, you are having loops H to H 1 of S, and this is your D of S value, and this is your G of S, and this is your H of S. This is value. This signal is called as this lines. It is called as a signals value. This one, and this is your block values we have to insert here. And next one is that this is your negative feedback. So this is your this is also called as a feedback loop, which is called as a negative. We have to mention -1 value. And next one, this is your value. And note with the signal input and single output can be eliminated. That is your x1 of s and your x2 of s values. Have to eliminate here this one and this one value. And next one is this is another more examples. This is your block diagram. This is your converting signals. That is your uh, flow of direction values. This is your each node. This one, this one, this one, this one, this one. All these. And again, this is converted into branches. That is your gain values and feedback values are all the elements are present. We have to simply notify your, which is in summing point, it is negative feedback or your positive feedbacks. This is your values. Here you have to eliminate these two nodes into single point, that is minus H2 of S, and this is minus H1 of S. This is your multiplication because this is a cascade connection. And the difference between R versus values of SFG and block diagrams. Uh, this is the signal flow graphs and block diagrams are alternatively equivalent. That is, block diagram means all the spaces your SFG or block diagram have to find out the transfer functions, which is a Laplace of output or Laplace of input. Your output value to the input value is called as a transfer function. In a SFG, where it is used means you are in state-based systems. There is no something state-based models and block diagrams which is deal with your transfer function, and these two are mostly applicable for your industry purposes. And your transfer function is found out by Mason's rules. That is, it is a simple formulas you have to in technologies. And this is your loop gain, that is g of s into h of s. This is your one of the loop gain, and this is also one loop, and this is also one loop, this is also one loop. Loop means that is we are having some input, and your example you have to see you have to input, and this is your output again. This is your forward path, again it is converted into here. So this is called as your loop, that is your output quantity is varied by your input quantity, which is there is no error signals, that is called as a loop gain. And this is your forward path gain, that is from input to your output, from starting to ending, what are the paths to receive your output, that is this is your one of your path, again one, this one, this one, this one, this is your one of the paths. So totally two paths is available. And how to find out your non-touching loops means here there is a four loops or sorry, one, two, three loops are available, which is not touched means this one not touched, and this one not touched. These two loops are touching together because in same direction the loops are inner and outer path. And how to find out the non-touching loop gain means this value into this value, again this value into this value, both are negative feedback, so your answer is in positive way. And this is your Mason's gain formula, that is transfer function T of s is equal to y of s divided by r of s, that is 1 by del summation k equal to 1 to p, pk and del k. Here p is the number of forward paths and pk is the gain of the kth forward path. K means how many forward paths are from input to your output. For example, there is a two path means k values is 1 and 2. And this is your del is equal to 1 minus summation of loop gains, that is your two non-touching loops, and 3 minus 3 non-touching and plus 3 non-touching and 4 non-touching, again it is go same as del k, that is del is equal to summation of k forward path. And this is your Mason's rules, that is in your this problems how to find out these all the values, that is here there is a two forward paths from this one, and again this from this one, two forward paths, and individual loop gains this one, this one, this one, and two non-touching loop gain is this pair, and again this one is a pair. And how to find out the del means del minus 1 minus your formula, two non-touch single non-touching and plus two non-touching minus three non-touching values. And this is your another more examples. The same examples here del 1 is equal to 1 minus 0. How means here 1 is one forward path is here, that is the three loops are which is touched in your first forward path, and second one this is your forward path means here also the loops are touching. So this is your values del 1 and del 2 values are 1, that is in first forward path all the loops are touched, so your values is 0, so always your del 1 is 1. And next second forward path, here also there is no non touching loops in the second forward path, so here values of del 2 is equal to 1. And this is you have to substitute the values, that is t of s is equal to here k is equal to 2, so p1 p2 del 1 del 2 whole divided by del. This is your final values of this SFG, that is block diagram to SFG. And thank you.